In February 2022, when Russian armored columns crossed into Ukraine, military planners across Europe were watching one number: tank count. Russia fielded thousands of T-72, T-80, and T-90 tanks, forming what was widely considered the largest active armored force on the continent. On paper, it looked overwhelming. But within months, the battlefield began producing images few had predicted. Heavy armor that once defined ground dominance was being stopped, stalled, and in many cases eliminated in ways that challenged long-held assumptions about mechanized warfare. This is not simply a story about destroyed vehicles. It is about what happens when military doctrine, industrial power, and modern technology collide under real combat conditions. Russia entered the war in February 2022 with one clear advantage on paper: mass. Before the first armored columns crossed the border, Moscow maintained one of the largest tank forces in Europe, with thousands of vehicles spread across active brigades and long-term storage sites. The backbone of that force included upgraded T-72B3 models, gas turbine-powered T-80 BVM tanks, and the more modern T-90A and T-90M variants. Elite formations such as the 1st Guards Tank Army were built around concentrated armored strength, and their structure reflected decades of planning for high-intensity ground warfare against a major opponent. For many analysts watching at the time, the numbers alone suggested that Russia could generate overwhelming pressure along multiple axes at once. But these tanks were not only tools of war, they were central to how Russian military power understood itself. Since the Cold War, armored maneuver has been treated as the core of ground operations, and that mindset grew out of Soviet deep battle doctrine, which emphasized breakthrough, speed, and exploitation of enemy weaknesses. In that tradition, tanks were not secondary assets supporting infantry. They were the main striking force meant to punch through defensive lines and create operational collapse behind them. This belief shaped training, procurement, and deployment, and it reinforced the idea that armored mass could decide a campaign if used with enough force and timing. The design of these vehicles also reflected specific priorities that dated back to Soviet engineering choices. Russian tanks use a compact autoloader system, which reduces the crew to 3 members and allows for a lower profile compared to many Western models. A smaller silhouette was seen as an advantage on open terrain, and the reduced crew size simplified training pipelines. The autoloader carousel sits beneath the turret, storing ammunition in a circular arrangement that feeds directly into the main gun. This configuration helped keep the tank lighter and more compact, which made it easier to produce in large numbers and transport across long distances. However, those same design features carried trade-offs that had been discussed in military circles for years. The roof armor on many of these models is thinner than the frontal arc, because the original threat calculations assumed horizontal engagements against other armored vehicles. The turret ring, which allows rotation of the main gun, is a mechanical necessity but also a sensitive point if struck precisely. The engine deck at the rear is protected against indirect fire, but was never optimized for repeated vertical attack. Most importantly, the ammunition stored in the carousel sits close to the crew compartment, which means that a penetrating strike can trigger a catastrophic explosion if the stored rounds ignite. These vulnerabilities were not secret, and NATO analysts had studied them throughout the Cold War while planning for a possible confrontation in Europe. War games often explored scenarios where top attack missiles or advanced anti-tank systems could exploit thinner upper surfaces. Yet those assessments were largely theoretical, because no recent conflict had subjected Russian armored forces to constant overhead surveillance and repeated precision strikes at scale. In previous wars, tanks faced artillery, mines, and anti-tank guided missiles, but they were not operating under a sky filled with persistent, unmanned observers. When Russian units began advancing in early 2022, they did so with a structure and doctrine shaped by industrial-era assumptions about mass and momentum. The expectation was that armored formations could push forward, absorb resistance, and create breakthroughs that infantry and follow-on units would expand. Instead, the environment they encountered was one where movement was tracked almost in real time, and where even small vulnerabilities could be targeted with precision. Those structural characteristics, once seen as efficient and practical, would soon meet a battlefield environment Russia had not fully anticipated. The turning point on the battlefield did not begin with a new tank model, but with a small flying machine that could be bought online and modified in a garage. As the war moved into its second phase in 2022 and continued through 2023, first-person view drones, often called FPV drones, became one of the most decisive tools in Ukraine's defense. These devices were originally designed for racing and hobby use, yet they were quickly adapted to carry explosives and guided by operators wearing video headsets. Unlike traditional missiles that follow fixed guidance systems, these drones could be steered in real time, allowing the pilot to search for weak spots and dive directly onto the top of a vehicle. The turret roof, the engine cover, and even open hatches became primary targets, and the vertical angle of attack bypassed armor that was designed for threats coming from the front. The pattern of attack soon followed a clear sequence, and many battlefield videos showed a similar story. A first strike would damage tracks or the engine, which stopped the tank from moving and left it exposed in open ground. A second drone often followed within minutes, hitting the turret or ammunition area and causing a powerful explosion. In other cases, unmanned aircraft spotted armored movement from above and guided artillery fire with high accuracy, while Western-supplied anti-tank systems such as Javelin and NLAW added another layer of danger. This created a battlefield where heavy armor faced not one threat, but several at the same time, and where survival depended on protection from above as much as from the front. The cost difference between attacker and target reshaped the logic of engagement, because an FPV drone often costs less than $1,000, while a modern main battle tank is worth millions. These drones are assembled from commercial parts, upgraded with simple explosives, and produced in large numbers with short training cycles for operators. If one is destroyed, another can be launched within hours, which makes them easy to replace in high-intensity combat. This affordability allows repeated attempts against the same vehicle, and it lowers the risk for the attacking side, because the loss of equipment does not mean the loss of trained crew members inside armored steel. Open-source monitoring groups began tracking the scale of destruction as the war progressed, and by late 2023 and into 2024, the numbers were difficult to ignore. The Oryx database, which counts only visually confirmed losses through photos and videos, documented more than 4,000 Russian tank losses since the start of the invasion. It is important to note that this method includes only vehicles that can be verified with evidence, so the real total may be higher or lower, depending on reporting gaps. Even when using cautious estimates, the level of attrition stands out as one of the highest seen in modern conventional warfare, especially for a military that entered the conflict with significant reserves. The strategic impact of these losses began to appear in equipment choices on the ground. Older T-62 tanks were pulled from long-term storage and refurbished for deployment, and reports emerged of T-54 and T-55 models reappearing in some sectors. These vehicles were originally designed decades ago, and although upgrades can improve optics or communication systems, their protection and firepower reflect a different era. The growing presence of legacy platforms suggested that sustaining frontline strength required tapping into deeper reserves, which in turn reflected the pressure created by continuous destruction of more modern variants. As months passed, it became clear that the battlefield environment had changed faster than Doctrine. Tanks were no longer facing only other armored vehicles across open fields, but were moving under constant observation from small aircraft that could strike at precise angles. This shift did not mean that armored units disappeared from the fight, but it forced a reassessment of how they could operate under persistent aerial threat. Faced with this level of attrition, Moscow did not abandon armor, but it began adapting under pressure. Russia did not stand still under pressure, and as tank losses mounted through 2022 and into 2023, the military began searching for ways to reduce the growing threat from above. One of the first responses involved electronic warfare systems mounted directly on armored vehicles, and these devices were designed to disrupt the radio link between FPV drones and their operators. Antennas began appearing on turrets, and some units deployed portable jammers to create a protective bubble around advancing columns. In theory, if the signal was blocked, the incoming drone would lose control and crash before impact. On certain occasions this worked, especially against basic models, Yet results were uneven because Ukrainian operators adjusted frequencies and used signal hopping to avoid interference. In some cases, drones were programmed to continue their dive even after losing connection, which reduced the value of signal disruption alone. When electronic protection proved incomplete, physical barriers began to appear on the battlefield. Welded metal cages were installed over turrets and engine decks, and these structures were meant to cause incoming explosives to detonate before reaching the armor beneath. Soldiers and mechanics built these additions in workshops close to the front, often using steel beams and mesh that were available locally. The idea was simple: create distance between the explosive charge and the vehicle's core. However, these cages added significant weight and raised the silhouette of the tank, which made concealment more difficult and movement slower. In some configurations, turret rotation was restricted and visibility from inside the vehicle was reduced, which created new operational risks even while attempting to solve another problem. As threats continued, extra layers of explosive reactive armor were added beyond standard placement. Bricks such as Contact 1 and Contact 5, originally intended to defeat shaped charges from anti-tank missiles, were mounted on upper surfaces that had not been designed for that load. Engineers and field crews hoped that additional protection on roof areas would reduce the impact of downward strikes. Yet these systems were not optimized for repeated vertical attacks by small drones carrying focused charges, and the extra mass placed strain on suspension components and engines already operating under heavy demand. A heavier vehicle is not only slower, but also harder to recover if disabled, which increases the chance that it will be destroyed or abandoned after initial damage. At the same time, the shortage of modern main battle tanks pushed the Russian military toward more unconventional solutions. Armored tractors such as the MTLB were fitted with naval guns, and reports described RBU-6000 anti-submarine launchers mounted on land platforms in certain sectors. These hybrid systems reflected a practical effort to use available stockpiles in creative ways, especially when industrial output could not immediately replace battlefield losses. Naval weapons offer high explosive firepower, and in theory they could deliver strong suppression against fortified positions. In practice, these modifications often affected balance and mobility, and the large structures mounted on relatively light chassis created visibility challenges in open terrain. All of these measures demonstrate adaptation under constraint rather than doctrinal overhaul. Moscow did not abandon armored warfare, and it continued producing and refurbishing vehicles, yet the changes show how quickly a force built for traditional mechanized combat had to adjust to a sky filled with hostile drones. Electronic shields, metal cages, added armor, and improvised weapons were attempts to restore survivability in an environment where threats came from angles once considered secondary. Some units reported limited success in reducing immediate damage, while others faced mechanical strain and operational limits that complicated offensive movement. What stands out is not the existence of countermeasures, because every military adapts under fire, but the speed at which these adjustments had to be implemented. Workshops near the front were redesigning vehicles in real time, and crews were entering battle with equipment that had been modified weeks earlier in response to new tactics. This cycle of innovation and counter-innovation became part of daily operations, and it highlighted how rapidly the character of the conflict was evolving. Nowhere were these pressures more visible than along key frontline sectors. The hardest pressure on Russian armored units became visible in specific sectors where geography and technology combined to create constant exposure. In areas such as Kupiansk, Vovchansk, and Pokrovsk, the battlefield turned into a zone of persistent surveillance, where unmanned aerial vehicles operated day and night and where thermal cameras could detect engine heat even in darkness. Small reconnaissance drones hovered above tree lines and fields, transmitting coordinates in real time, while artillery units adjusted fire within minutes based on live feeds. This level of transparency reduced the value of concealment and made every movement easier to track, especially for large armored vehicles whose heat signature stands out clearly against cold terrain. The main challenge for mechanized units in these regions was not always the clash itself, but the approach. Armored columns moving along roads or crossing open ground were often detected early by reconnaissance drones, which allowed defenders to prepare strikes before direct engagement occurred. Instead of facing enemy tanks across visible lines, many vehicles were hit during transit, sometimes kilometers away from their intended objective. In several recorded cases, a tank would be struck while maneuvering toward a tree line, and follow-up attacks would occur before the crew could establish firing positions. This shift meant that losses happened during movement phases, not only during active combat, which altered the tempo of operations and forced commanders to reconsider how and when to advance. Combined arms coordination also played a critical role in this environment, and gaps in protection increased vulnerability. When armored units advanced without close infantry support, they lacked immediate defense against small aerial threats that operated at low altitude. Short-range air defense systems were present in some formations, yet coverage was not always consistent across all sectors. Electronic warfare assets were deployed, but their availability and range varied depending on terrain and logistics. Without layered protection, heavy vehicles became exposed targets under constant observation, and even a brief halt could attract rapid response from drone teams or guided artillery. The operational consequences of this pattern were measurable and visible over time. Increased exposure raised the risk for crews, especially when mobility was lost and evacuation options were limited. Slower advances became more common as commanders adjusted to the risk of being detected during daylight movement. In some sectors, assaults shifted towards smaller groups or nighttime maneuvers in an effort to reduce visibility, yet thermal imaging technology limited the effectiveness of darkness as a shield. The result was a more cautious tempo, with armored units moving in shorter bursts and pausing more frequently to reassess threat conditions. Statistics from open reporting show that intense fighting in eastern sectors has led to repeated equipment losses during offensive pushes, and while exact numbers vary by source, the trend points toward attrition occurring before breakthrough could be achieved. This pattern reflects not only tactical resistance but also the influence of geography, as open fields, limited urban cover, and narrow supply routes create predictable movement corridors. When such corridors are monitored from above, any large vehicle becomes easier to track and engage. It is important to note that this environment does not eliminate tanks from the battlefield, because armored platforms still provide protection, firepower, and psychological impact when properly supported. What it does is punish isolated movement and reduce the margin for error. A tank advancing without infantry, air defense, and electronic cover is operating under conditions very different from those assumed in earlier doctrines. In sectors like Kupiansk and Vovchansk, this reality became part of daily operations, and the geography itself amplified technological advantages held by defenders. Behind these battlefield patterns lies a deeper issue that goes beyond tactics. The deeper shift in this war is not only tactical, but economic, because the cost gap between attacker and target has reshaped the logic of attrition. A modern T-90M is widely estimated to cost between $4 and $4.5 million, depending on configuration and upgrades, while an FPV drone used to disable it may cost less than $1,000, including explosives and modifications. This imbalance creates a strategic problem that goes beyond the battlefield, since the side losing expensive platforms must replace them through long production cycles, while the side deploying low-cost systems can scale quickly with limited investment. When a machine worth millions can be damaged or destroyed by a device that fits in a backpack, the traditional relationship between industrial weight and battlefield power begins to shift. Industrial capacity remains central to this equation, and Russia has not stopped producing armored vehicles despite heavy losses. Facilities such as Uralvagonzavod continue assembling and refurbishing tanks, and state media frequently reports increased output and extended factory hours. At the same time, large numbers of stored platforms are being modernized and returned to service, which allows Moscow to sustain frontline units even under pressure. However, manufacturing takes time, and high-intensity combat can consume equipment faster than factories can deliver replacements. When destruction rates outpace production during peak fighting, the strain becomes visible in deployment patterns and equipment age. The issue is not limited to steel and engines, because armored warfare depends on trained personnel as much as hardware. A tank commander requires years of experience to develop tactical judgment, coordination skills, and familiarity with complex systems. Gunners and drivers must also master technical procedures under stress. And these abilities are not easily replaced after a single training cycle. When experienced crews are lost, the force must rely on newly mobilized soldiers with shorter preparation, which affects operational performance and unit cohesion. Attrition therefore impacts not only inventory levels, but also the long-term quality of the force. As months passed, another pattern emerged in equipment composition, and modern stock gradually declined relative to older variants. Reports from the field indicated increased use of legacy models that had been stored for decades, and while refurbishment can improve optics or communication systems, it cannot fully match the protection and fire control of newer designs. This reliance on older hardware reflects both necessity and industrial reality, especially under the pressure of sanctions and limited access to certain imported components. When supply chains are disrupted, replacement parts and advanced electronics become harder to secure, which adds complexity to maintenance and production. Long-term strategic pressure builds slowly but steadily, and it affects planning horizons rather than daily headlines. Sustaining large armored formations requires steady flows of engines, armor modules, optics, and trained crews, and each of these elements faces constraints during prolonged conflict. Even a country with significant reserves must calculate how long it can maintain replacement rates under sanctions and export controls. Over time, this calculation shapes decisions about where and how to commit remaining high-end assets, and it influences whether older systems remain in service longer than originally planned. For American planners and observers, the lesson extends beyond a single theater of war. The Ukraine conflict demonstrates how inexpensive precision systems can challenge expensive platforms that were once seen as dominant. It raises difficult questions about procurement priorities, force structure, and the survivability of heavy equipment in a battlefield filled with low-cost sensors and guided munitions. The issue is not whether tanks remain useful, but whether their protection, integration, and cost structure align with emerging threats. Yet this transformation does not point to the end of armored warfare. The war in Ukraine does not show that tanks are useless, but it does show what happens when heavy armor moves without full protection in a modern sky. Since February 2022, Russia has leaned on mass and old doctrine, yet the battlefield kept changing faster than its formations could adapt, and open-source tracking has documented more than 4,000 Russian tank losses since the invasion began. When cheap FPV drones can strike a turret roof or an engine deck, and when artillery can be guided by live UAV video, a tank becomes less like a breakthrough tool and more like a high-value target unless it is covered by infantry, short-range air defenses, electronic warfare, and constant scouting. That is why Russia's improvised cages and turtle shells appeared. And that is also why the losses continued, because patches cannot replace full integration. For the United States and its partners, the lesson is cold and practical. Expensive platforms survive only when the whole system moves together. If you want more clear, fact-based breakdowns like this, subscribe to Military Force and tell us in the comments which weapon system you want us to dissect next.